Have you ever stopped and wondered what is actually happening inside your computer? I mean, really happening, deep down. Today, we're diving into an incredible journey called Nand to Tetris. It's a project created by Shimon, Schocken, and Noam Nisan that completely demystifies computing because it guides you to build a computer from the absolute ground up. And it all kicks off with one simple question.
You've been there, right? If you've ever written a single line of code, you've witnessed this moment. It feels like pure magic. You type some words into a file, you hit run, and bam, things just happen on your screen. But how? How in the world does that abstract text you wrote turn into a real, concrete action? Well, that's the central mystery we're going to unravel today.
So, is it magic or is it science? Well, it sure feels like magic, but of course, we know it's science. And to really get it, we've got to pull back the curtain and stare into that massive gap between the code we write and the hunk of metal and silicon that actually runs it.
Look, it doesn't matter what language you're using, Python, Java, you name it. The computer itself doesn't understand a word of it. Your beautiful, elegant code has to get translated into the only language the hardware actually speaks, machine code. And that's just a long stream of ones and zeros. That's it. Those are the fundamental instructions for the processor. For most people, even for a lot of experienced programmers, this whole translation process is a giant black box. I mean, how does something as simple as a for loop really work at the hardware level? What is a compiler actually doing? And how does a string of binary code tell a physical machine to do anything at all, whether it's running a game or just putting text on a screen?
So, how do you pry open that black box? Well, the Nand to Tetris approach is both radical and incredibly simple. You don't just study it, you build it yourself, from the very beginning. It's all about understanding something by actually constructing it.
You know, it's kind of like learning about a car engine. You can read books about it all day long, but you'll never truly get it until you take one apart and put it all back together again. That's the whole idea here, to build this deep, intuitive, first-hand knowledge of how every single little piece fits and works together.
So, what is this journey exactly? You start with the most basic, most fundamental building block of all digital logic, a single NAND gate. Now, why NAND? Because, and this is amazing, every other logic function you can think of, and or not, can be built just from NAND gates. From that one single primitive, you build everything: the CPU, the memory, an operating system, and eventually a full-blown computer that can actually play Tetris.
All right, I know what you're thinking. Going from one tiny little logic gate to a whole computer? That sounds like a massive, impossible leap, but it's actually broken down into a super clear, constructive path. Let's take a look at the major steps.
So, it all starts with that NAND gate. First, you combine these gates to build a whole family of basic logic chips. Then you take those chips that you just made and you use them to build the core architecture, a CPU and memory. And finally, you put all those pieces together into a complete working computer that we call the hack platform. Each new layer is built only from the parts you created in the step before. It's like building with digital Legos, brick by brick.
Now you're probably wondering, okay, this sounds pretty amazing, but how do I actually build a computer? Do I need a soldering iron and a garage full of electronics?
Don't worry about it. You can put your toolbox away. This is not about building a physical machine.
Instead of physical tools, you use a special piece of software, a hardware simulator. You're building a virtual computer, designing and testing every single component right there on your laptop. And hey, this isn't just some academic toy. This is exactly how modern chips at companies like Intel or Apple are designed today.
And what's really incredible about all this is how accessible it is. You don't need a background in computer science or electrical engineering, none of that. The course is completely self-paced, it's broken down into these core projects, and it's really just designed for anyone with a curious mind. So why? Why go on this journey? What's the real payoff for peeling back all these layers and understanding this machine from the very first principles? Well, if you're a developer, understanding your enabling technology, the actual machine your code is running on, makes you a way more sophisticated, more effective professional. But even if you're not, if you're just an intellectually curious person, you gain this fundamental literacy in what is arguably the most important machine of the 21st century.
The creators of the course put this into a really powerful context they call BANG. The idea is pretty simple. To be scientifically literate today, you need a basic handle on 4 pillars of knowledge: the physical world, which is atoms, the digital world, which is bits, the biological world, genes, and the cognitive world, neurons. This journey gives you a deep, foundational understanding of bits.
By the end of this whole thing, you won't just know that computers work. You will truly understand how they work, all the way from that first logic gate. You will have closed a fundamental gap in your knowledge of the modern world we live in.
So what are you waiting for? As Shimon, the creator, always says to kick off the course, there's really only one thing left to do. 1, 0, go!